Let's start.
All right, awesome. Then let me start maybe. So welcome all who's already here and everyone who's joining. We will talk today about the topic of fast and reliable rollouts, especially in the automotive industry, because that's the industry which is has some other characteristics, for example, when we compare it to pharma or metal processing and so on. So we will talk about that. My name is Rybakowski. I'm responsible for the partner management at Cybus. So basically talking to integration and bigger consulting partners who are then guiding automotive customers through projects and in general digital strategic initiatives. So that's my responsibility here. Steffen, maybe do you want to introduce yourself as well?
Thank you, Danny, and also a big hello from Munich from my side. My name is Steffen Eisele. I'm responsible with a team of experts mainly for the German-speaking countries, of course, for continental Europe, Scandinavia, and Benelux, and we serve our customers all over the world. And from me and Sensei, just a few words. What are we doing? We have a very unique application for predictive maintenance and prognostics. So yeah, very happy to talk with you today, Danny.
Happy as well. So maybe to introduce the company just real quick, what we're delivering is basically a factory data hub for companies. So traditionally also called middleware. And I think that should be sufficient for now. We can get into that throughout the conversation. All right, Steffen, do you want to start or should I start? I have a lot of questions.
I would like to hear from you, Danny. What are your typical requirements when a customer approaches you and wants to have support in automotive industry? And I guess we could have an idea when we're talking now about automotive. Of course, these are some ideas, suggestions for all kind of manufacturers to do a, let's call it easy and fast rollout. What requirements, Danny, do you normally have?
So when we're talking about automotive, normally production is characterized by, I would say, most of it is assembly with some quality assurance along the way, but some painting, but most of there is always assembly. And when we look into a typical production on the shop floor, we have normally hundreds or thousands of different devices, PLCs from different manufacturers, talking different protocols of different ages, so legacy machines as well. And on the other side, we have different IT systems, like typically from like an MES, PLM software, or quality management software, but as well an ERP. So we have different tools there, and typically all of that landscape which we have, there's this requirement we see a lot is it needs to survive at least multiple cycles of productions of like car productions. So typically 5 to 7 years. And now if you try to introduce different use case into that landscape, we have like digital use case, for example, for predictive maintenance, or if you want to do some monitoring and so on, then you see yourself challenged with a very high dynamic on the one page because all the systems are changing constantly. And on the other page, we have a very high data throughput, right? So what you need in order to manage all of this, you need to be very lightweight in terms of it needs to be very fast and easy. So it means building applications or use cases always like between shop floor and the IT and enterprise. So building that needs to be very fast and efficiently. Then managing all of this because we're having multiple use cases with lots of data throughput. We need to manage all of this. Need to make sure that nothing here gets lost because you have that's as well very typical. We have very high documentation requirements. So that means, for example, to document for the end customer as well for suppliers, how was typically something produced. So how was the product? What was the pressure used for it, for example, right? What was the temperature when you've been welding? All of this needs to be tracked. If you're not able to track that, most of the cases you can throw it away. So it's very important to actually track all of this and make sure that none of the data gets lost, even though you're having different projects which require that data, right? So you want to read different data, but at the same time, you need to make sure production is at all time running and it's not stopping, right? So that's more or less, I would say, the environment we find ourselves in. Yeah, so, but that's from our perspective. You might have a little bit different perspective, maybe some for your experience. What would you say, what requirements matter the most in the same, so as well in automotive, especially when we're rolling out, right? So we're not talking about smaller projects, pilots, but rolling out bigger digital projects in the automotive sector.
No, you're totally right. It's all about the data. It's having about the right data at the right time, at the right place to make the most benefit out of it. What I just want to mention, and this is a little bit to the opposite, because when customers, also in automotive, often want to start a project and come towards us, it's often about the digitalization center or the tech lab or the new businesses or new solutions department unit that want to try something. And so this is something, what you already said about the global approach, this is something that makes it a little bit more difficult, or could be worse because it's not working. Why? When they isolate some data from some machine, from some assets, components, and want to have a trial with that, as they always call it, or a proof of concept, it doesn't display the reality. That means it could work in that environment, but afterwards we have the problem to scale this because other assets need other data, and they are often not aware how to get those from the shop floor to where the data are needed. That means other departments have to be involved at the beginning of this, need to have the commitment. When we're doing a proof of concept, let's have a more global scope about how is it working for the whole shop floor? How is it working for the whole production side? How is it working for the other plants here in Europe, America, where else? It has to be a more general approach to have an idea, what do we want to do and how shall we want to do it? Just to have in mind, there's no general blueprint about that, but to consider all the different requirements from other countries just to make this as easy and as smooth as possible. So this is something, not thinking in a small trial, in a POC, do it bigger and do a little more general approach to that. Am I wrong?
No, I'd say I agree like 100%. So when we normally talk about this, I see like, and we can like categorize into like three, to make it easier, like three categories, which is normally like technology, which you need the right processes and the right people. And especially, I mean, what you're mentioning right now is the whole process side, right? When we look into those projects, the questions like when you start something small, and that's actually good, like starting small but think big, right? I agree 100%. But if you only think like start small and think small, so like in terms of the lab environments, then suddenly when you move this into production, like all the requirements, they change completely, right? And what we want to do normally, or like how we see this, how can you structure all of this? So you normally have the, I would say, shop floor responsibles, business responsibles, and the IT in between, right? And if you try to simplify it, that normally you have different use cases, and the needs is generated by the business side, right? And they know basically what data they want. And on the other side, you have all the maintenance responsibles and shop floor responsibles, who then know where the actual data lies, right? What PLCs can deliver the data? Is the data even there or not? So they know where the data is. And then you have normally right in between, in the sandwich position, is the IT, which needs to deliver all of this. And that's the process which you basically then need when you want to roll this out into multiple use cases and make this part of your, basically, of your company. So you need that process. How does this work? And if we would like to envision this, for example, if we take a look, how does it work with SAP? If there's a demand for data, then someone from the business side will like create a ticket to the IT, and the IT will need to deliver the data, right? So in that terms, the IT needs to like check with the maintenance, where's the data? Do we already have the data? If not, what we need to do to deliver the data? Do we need some, at the machine, some retrofitting? Do we only need to extend the data endpoints? we have already connections there? And then they are responsible to basically deliver the data internally to the business to the business users to basically execute all the use cases. And that's what we see there on the process side. And then what many approaches, get wrong is as well to pick the right technology, right? To deliver this, you need to pick a technology which is made for those big setups, which enables you to do rollouts. So we're not talking about like having different Raspberry Pis, putting some Node-RED on it and like getting data from that, right? So this will like create a lot of headache and it doesn't scale at all. So what we're talking about here is basically using what we refer to as DevOps principles, and if we apply this to the industry. So we're really talking about how can you, basically how can you execute updates and changes into the running production without interfering with the right production, right? So we're talking really about like industrial DevOps principles, as if you want to have a continuous integration pipeline, basically, which enables you to deliver those changes through a staging system so that you first can test changes and then basically make sure, all right, everything is fine. And then you can like make them part of the production environment so that the line never stands still. And as well, you can track changes. So who made what changes? You can as well restore the system status and like in case of the worst case that something's not working out, right? So all of that is, when we're talking those requirements at the beginning, that's what's necessary from a technology side. So you need to pick a technology which is ready for scale. So when we're talking about industrial DevOps there. But maybe to take one step back as well and look into the organizational structure. I know that you have there, and we talked about this like most of the time. So there's always as well a shift in the organization and the cultural shift, which we discussed. Maybe you can let us know what's your experience there, what needs to happen at the customer side.
Yeah, thank you for those insights, Danny, first of all. And I just saw we don't want to run out of time because we want to have a Q&A session afterwards. But thank you for this. Exactly, we were talking now about data and connectivity and having those available. Of course, this is important, otherwise it will not work. But I think there's a second factor that is often very, very much underestimated, and this is the cultural change in the human behavior for the humans in those digitization times. I mean, we have changes of job descriptions, we have changes of workflows, of processes. So it's not about alignment of IT, of the departments, production cells, whatever. No, it's also about the commitment from user side, from management side to stand to those processes, that something is changing, that changes will happen. I mean, there's no if or not, it is happening. The question is when. So we always have to have that human factor in mind about keeping those aligned with all those, and being happy with the changes, being happy with what is happening, what is new, and where's the benefit for all. I mean, it's not just about numbers, it's also about helping the humans. Yeah, but when we're so right now, a little bit in general talking, how about such projects, Danny? Is there a best practice that you have seen so far in global rollouts? I mean, a POC will work, maybe a site will work. How about the global thing? Can you tell me more about that?
Very good question. And I think there's not like a blueprint, as we said, because like each customer is very different, but we've seen some, I would say, some patterns along the way which work very good. So most of the customers we work with in the automotive sector, and I think that's a no-brainer, they start small. So start with one factory showing it works there with one use case, and at the same time, but making sure you have the right persons in place, they have the buy-in, right? So you have someone who owns the whole digitalization across the factories. Then secondly, you're going to enable persons. So you have a dedicated team who has the competency to basically do all of these rollouts, right? Who is basically, if you would compare it to SAP power users, now you would have like those technology power users who can implement this and train local users in other factories. And thirdly, since I would say you have your own productions and your own capacity, most of the customers we see, they always work together with bigger partners, right? So they always work with bigger consultants, integration partners, because you need someone who's doing the project management, who's doing the consultancy, who's doing the integration, because it takes a lot of energy and time at the beginning, right? And as well, you want to make sure that you have the best of breed approach and see what's as well there in the market. So we see basically, I would see those three are the things. So we always start small in one factory, then roll out to the other ones. You have someone who's responsible for all of this across the organization, and you normally work together with partners to implement those, or you have a very strong team internally as well who would make this possible. So, Stefan, I'm looking at the time right now.
One last.
And I'd say, yeah, and I would say last time when we talked, we didn't manage to put in a Q&A session. So we want to really do this time. So I would say maybe last words to you to this kind of topic, and then we start with the Q&A session. Maybe you can start off why, I mean, at the end, why are we all doing this, right? So what's the aim of this digitalization? And then let's kick off with the QA session. So everyone who's here is welcome to throw in some questions, and we will answer all of this. If the time is not enough, we will we'll follow up on that later.
Yes, please write us your questions. We are happy to answer them. I try to make it short. I always get very passionate about our topics about digitalization, but try to keep it short. Why are we doing this? I mean, it's not about having data. It's about getting benefit out of the data. That means get those data where we want them to, analyze them, visualize them, monitor them, and just to make better decisions out of that. It's about when you know what's happening right now and what will happen in the future, for example, in your production, on your machines, in your logistics, in your assembly lines, then you are able to do better decisions. And we do nothing else with the data that you deliver, Danny. We enable our users, our customers, to do much better decisions. Going away from firefighting, going away from the plant maintenances, about just going into action when it's really necessary. So that is what I always say. It's just about being able to do better decisions. So that's what my 2 cents to that.
Understood completely. So I mean, I can answer this as well from our side. So what we see basically where we want to go there is what we're really trying to do, and what we see companies trying to do, is get in control of the supply chain, right, of the value chain. You want to have everything transparent and be in control, because you have so many changes, especially right now, right? You have the semiconductor like crisis, you have an energy crisis. At the same time, most of the manufacturers are changing to energy. I mean, like in terms of electrical vehicles. So there are a lot of changes, and you need to be prepared for this. And you need to make sure that whenever something happens, you can adapt very fast. So for that, you need to pick like processes and technologies which allow you to adapt. So basically, it's all about having this data available and making this data available at the right time for the right person, so you can then work very fast, right? So we're always talking about time to impact. That's what we are always focusing on at Cybos. And yeah, I'm glad to talk about this as well. Maybe another session. Let's take a look. As I can see, there are still no questions there. So I would say, please go along, ask questions. There are no stupid questions. But in the meantime, I prepared some questions which we get sometimes as well from other partners when we talk to them. So one typical question, for example, is what we get like, how fast can you be using industrial DevOps like principles, right? So we always talk right now about the technology, but if you compare it, like what are the advantages? And to give you one example, maybe at one of our customers, we connected a welding robot from KUKA. It was done via MQTT. So the case was there to basically track what are the welding curves, right, and push them to the cloud for analytics. So to see basically afterwards how are the robots performing. And for that, we had to connect over 150 of those robots in those assembly lines. And so the first robot, I think, was roughly 50 minutes to connect because it was quite easy. And all the other remaining ones, we were able to connect as well within 10 minutes afterwards. So how is this even possible? It's because of the use of the technology. So if you use a so-called approach, infrastructure as code, is where you actually don't drag and drop things, but actually code them. So that means you can reuse those configuration files and only change, in that case, for example, the port and the host. And so basically, where's this robot inside the network, right? And what's the firewall settings there? So you can change those network settings. That's the only thing you can write, a playbook, and then basically connect all of the other robots in like very high speed. And then as well, if you want to then go on and like change something, you can as well change one of those configurations globally, some parameters. For example, you would say, I want to have changed the interval of what data is incoming, right? Because maybe you don't need it in the cloud in every second. Maybe you want to have it all every minute. That's sufficient. I mean, it's always a cost thing. So you can change it very fast as well at one point and roll out it globally. Yeah, that's something we get a lot of people ask here.
I see another question. Where's the budget normally coming from? Very good question. As we mentioned it before, it's about commitment between all the other, between different departments. I mean, in our case, it's the production maintenance department and the IT, of course. Sometimes the first projects are sponsored by the digitization labs or tech labs. But to be honest, all the budget that is following is coming then out of the IT. So that is what I also was a little bit surprised after quite a while working for Sensei. It's not about the maintenance who's paying for that. It's always, or most of the time, really the IT department who's the sponsor for those kind of projects, even if it's for specifically production, specifically for the maintenance departments, because it belongs to the digitalization strategy, and so IT is responsible for that. So just to get an idea to all the production leaders or maintenance leader or maintenance guys, involve the IT teams, that they are aware that you want to do something, and if we're successful with the pilot, be aware with whom we have to talk to.
It's funny you're mentioning that because we perceive it very similar. So I would say in most of our cases, the IT has the budget there. But last time when we talked to Gartner, for example, we were told actually 25%. So of the budget owners are the IT, but most of the cases, so 3 out of 4 cases, is not the IT, right? And those are not the exceptions. That's most of the reality. So of course there might need to like a shift might be necessary. But on the other point, how can you actually then how can you operate with the budget if that's not the case, right? If the IT doesn't have the budget, then we have some customers as well like that. Then we're normally talking about a shared cost center, right? So it could be some internal, I would say, changes you made, for example, that when the IT is providing something, you can basically put this to invoice that to another department, or you can basically say, all right, the IT is a shared cost center for all the other departments.
Yeah,
that's something we see a lot as well. So
yeah, we often see a pool at the headquarter, and then all the different sites are taking whatever they need. So we could call it a on-premise, something like this. Yeah, but we have another question, which is very, very interesting. I just want to understand it in total. I just read it for you guys. I heard that modular production is in planning for Industry 4.0. What are your thoughts about it, and which problems could come with that or could come up? What exactly is meant with modular production? In what specific way is it meant?
Maybe I can elaborate on that. I mean, in the meantime, maybe Julian can elaborate it as well. But when we talk about modular production, and I know it as well from projects like from DMG Moli, for example, when they talk about you have a production line and you basically can change, like interchange small parts of it, right? For example, a robot, you can change one part of the whole assembly line. And then, so in terms of you want to change the product. So changing product A to B, that means sometimes that maybe you can have, maybe the conveyor belts can stay the same, maybe the welding robot can be the same, right? But maybe if you then look at another machine, right, some drilling machine, maybe you need to change that, right, because it requires other tools there or another like machine setup at all. So it's faster than to interchange and module of the production line. That's something I specifically don't see a lot. I don't know how about you, but so it has its ups and downs, obviously, of course. I mean, if you talk about flexibility, that's what it gives to you, right? It gives you flexibility, and that's what you want to have in that case. Exactly. And like technology-wise, you can very easily like integrate it then, because it's just like if you take a look at it, it's another source. You need to connect those different PLCs and different like parameters there and make the data available as well for the different use cases. So that's feasible. But yeah, Steffen, maybe you want to conclude on that as well.
Exactly, the flexibility is one of the keywords. I mean, we always have to be honest. The digitalization is in this state that we're right now is quite new with some topics to some people. So flexibility and a general approach is always suggested. For example, I see a lot of issues and challenges when people are addressing us or coming to us and talking about their challenges. You should have a solution that is working with most of it. I mean, we have an agnostic solution about predictive maintenance. So it makes sense to have that as a solution, not for turning equipment or something else. It's really about what is able to be used in any kind of color that I have so far in my production site or wherever in logistics and so on. So it's really good to have a general view on that and to talk to your partners about the experiences that you made, for example, with the industry, with competitors of you. I mean, of course, there will no data shared, but we did now so much global rollouts and so much pilots where we have just such a big experience, and people should just use that. Yeah, just make use of our knowledge.
I would like to extend on what Julian asked, and because I just had another interesting take, maybe. I mean, one thing is to change the actual production module, right? This might be made quite fast, right? So the production is still running. But what about all the other use cases above which rely on the data, right? So what you want to do in that case is make sure to, when you change another module, another system, maybe it's a new one, and then you want to use the data real quick for predictive maintenance, for example, right? Or for some other analytics or for some reporting. You want to, whatever you used it before for your digital use cases, you want to like include it as well as fast as possible. And if you have, for example, now some machine learning that requires certain data in certain formats as well, right? Needs to be prepared, pre-processed. So you want to make sure that all of this is not a whole new project, but as fast as possible. And another take there is, I know, is what you need to consider there is having a data model in place, which allows you to integrate the new data into it as fast as possible, right? So, and we can talk as well, for example, about digital twin. And the question would be, is it an asset digital twin or a process one, right? What are we talking there? But I would say that's the key there, having a system in place. So basically a data architecture where you can integrate the data very fast, put it into a certain format, which matches all the other ones which you had before. So you can integrate it very fast from this, then I would say, from this same data model into other applications, so that you don't lose time for basically doing data engineering. That's how I sometimes heard from colleagues which work for data, which are data scientists. Then they get sometimes they get Excel sheets with lots of data, and they like first 2 months what they do, what they get paid for is basically doing data cleaning, right? Data pre-processing, making sure they can work with the data. And that's not the sense of like Industry 4.0, right? You want to work with the data and not work like talk about the data.
Exactly. And this must be considered beyond the background that a lot of products, maybe shoes, maybe motors, or what else, are more individualized and more individual in the future than it is right now. Just for an example, our Siemens colleagues, when they build motors, in theory, there are no two motors exactly the same when they do the configuration that the customer is able to do so. So it's really about flexibility, and a lot of things will change within the next 5 to 10 years. And yeah, maybe we can use our lessons learned, and of course there will be some new lessons learned afterwards. But the changes that we are facing right now are very fast and very interesting.
I agree 100%. Steffen, I need to take a look at the time. We are 2 minutes over time already. So
as normally.
Yeah, thank you to all who participated. If you have any follow-up questions, make sure to ask us. The emails, I think, were, do we have the emails? Maybe Steffen, you want to post your email there as well, so people can ask the questions directly. That goes faster normally. There we go. Someone uploaded the slide. Perfect. Thank you very much. Garrett was moderating that in the background. So as well, if you guys like, you're happily invited to join us at the SPS fair, which is in Nuremberg in November. There will Steffen will be there. I will be there. So happy to meet you in person as well. Yeah. Other than that, last words to you, Steffen.
Oh, thank you very much for having us. Thank you for being able and partner with you. Always happy to talk to you. Always happy to exchange. I'm happy to see you first time on the SPS in Nuremberg. And yeah, as you said, I'm there also for every 3 days. So feel free to join us at the Siemens booth.
All right. Thank you all. Bye-bye.
Bye-bye.